Hey everyone, Ashok here with another video on data science training. Today we're going to discuss or learn about a very important package in Python for data science called Numpy. Numpy is literally means numerical Python. Is originally created by Travis Oliphant in 2005 as a community project. And since then, Numpy has been extensively used for all sorts of manipulating large multi-dimensional arrays and matrices. Along with a large collection of high-level mathematical functions, Numpy is really useful for data science. It's one of the core package for data science. Alright, so let's get started. I'm using Jupyter Notebook. If you're not sure what is Jupyter, you might need to check a module 1 video which has instructions to install and use Jupyter. Okay. Alright, so yeah, this is quick agenda for this session, like Numpy package overview, which we already did. Importing Numpy, if you are installing Anaconda distribution, which I did, Anaconda distribution, you can just Google for Anaconda download and it takes you to Anaconda download page. Oh, not this one. Go for this. Yeah, it is taking a bit time. Alright, Anaconda download, and you can click and download Python 3.6 version, which is the current version as of today, and install it. You can select 64-bit or it's predominantly 64-bit. If you are using 34-bit Windows, accordingly it will show the corresponding things. Mine is Mac and it's picking up this version. If you install Anaconda, and Anaconda comes with Numpy, Pandas and many other important essential data science related Python packages. If not, you might have to install manually. You could actually download it. If you have Python installed, you can download Numpy directly from the Numpy package and install it. But I highly recommend it to go with Anaconda. That's the easiest and most efficient manner. Okay, let's get started with, once it's imported, you need to import it in this Jupyter notebook. We do that using a command import numpy, and I call numpy as np. That really is a short name for it, so that I don't have to type in numpy all the time when I want to refer that. That basically gets you a numpy imported. And let's start with few concepts on arrays. So Numpy works with arrays. So if I want to initiate a static array, I could go ahead and say a is a variable name is equal to, I would say np for my Numpy package. Array is a function which converts, I'm going to give some numbers like random numbers, and this will give us an array with 5 elements which I've given over there. Really easy. A few basics on arrays. Arrays are homogeneous data types, which means objects, which means you cannot have different kinds of types in one array. What I mean by that, let's assume that I assume that you have knowledge on integer, float and other things. If not, again check back my other videos which talks about Python basic data types and stuff. So this is an integer array, 1, 4, 7, 4, 9. If I make one of this element as float, let's say I want to make it like 4.2. So it's 1, 4.2, 7, 4, 9. Still 5 elements. If I just execute this one, you can observe that all the other elements are also upgraded into floats. Okay? That auto typecasting. So Numpy array looks at the variables. It looks at like 4.2 is a float, so it converts all the other elements in float as well. We have a little function called arange or array range. We used to generate a random array with a sequential number. I say that a is equal to b is equal to a range, that's the function, and I give 10. This command gets me an array uh, with 10 elements starting from 0 to 9. It's a really small handy function. So I want to create an array of 20 elements. I can do that by, sorry, Ctrl Z. That's it. It's that simple as that. Why do you need to create an array? Well, for experimentation, sometime you might need to generate a sequential array. We use this function. This is a single dimension array. What I mean, it just has one dimension. It's 0 to 19 or 20 elements in one row. There are a couple of attributes we use to know what kind of array, what's the dimension of array. One of the attributes you use here is n dimension, n dim. That will give us 1 because it's one dimensional array. Let me create a two-dimensional array. I can do it by static assignments like this. I would create a two-dimensional array with 1 and 2. Sorry. Okay, I don't know why I'm supposed to get a comma. Okay, it's comma, right? Perfect. Sorry. And 4, 5. So this is a simple two-dimensional array which has 1, 2, 3, 4 in. Oh, let me print it as well. As you can see, it's a two-dimensional array which has two elements in first row, and in the second dimension you have two elements as well. Pretty straightforward. I can also create multiple dimensional arrays by using a range and another function called as reshape. How do you do that? Here we go. MP a range. I want 30 elements. Okay. And if I just execute this, I'll get flat 30 elements or 30 numbers from 0 to 29. I could also add a dot and another function, which is basically this output goes to another function called reshape. And I could reshape it in different dimensions. Let's say I want to reshape it in a two-dimensional array with 5 by 6. So 5 rows and 10 columns, if you want to call that. That's simple. It's quite straightforward and simple. Okay, so there is another small function attribute which you can actually use to know the shape of the array, like how many rows and how many columns, like the dimension. So it is 5 by 6. Of course, we have put it 5 by 6. We are getting 5 by 6. All right. So shape, it's an attribute of Numpy array. It gives you a shape, and you know the dimension already. N dim. You are expecting 2 here because it's two-dimensional array. Okay, and there is also another small attribute called size. It gives you number of elements. So obviously you are expecting 30 because there are 30 elements over here. These tiny little attributes really help in understanding the structure of the array. In the previous tutorial, we talked about the type function, the Python type function, which gives you what type the particular variable is. Let's check out what type this is. Well, as expected, this is Numpy n-dimensional or ND array. Okay. Let's go to other functions such as zeros. There are certain situations where we create zeros for just understanding purpose. There is a function called zeros which will create you an array of zeros. I can give the dimensions 3 by 4, so it gives me 3 by 4 array. Sorry, data type is not. Oh, sorry. So I have to mention it. Double brackets. All right, so that we have a quick 3 by 4 array with zeros. I'm not going to go through where we are using it. That we will talk about in the further tutorials. This tutorial is just to make you comfortable with a few basic key commands in Numpy. Okay. All right. I can go and experiment with a lot of other stuff in using these commands, different dimensions. For example, let's say I'm creating an array with a range. I have 10 elements and I want to reshape it as 5 by 3. All right, great. Do you think it works? No, because we have 10 elements. How do you restructure it into the shape of 5 by 3? Because if you want to have an array of 5 by 3, you need to have 15 elements. You cannot reshape 10 elements into 5 by 3. Right. So if you put 15 over here, and as you expect, no error been thrown. And if you just display it, you have an array of 5 by 3. Right. I recommend to practice and do a couple of different variations to understand a range and reshape how it works. All right. Moving forward to other commands, we have commands which is very useful typically in data science analysis, and one of those commands in Numpy is vstack. Vstack, as the name implies, vstack basically means you're vertically stacking arrays. Okay, let me quickly define two arrays. Z is equal to np array. I'll use a range rather than this. That's easier for me. A range and vstack. So I want to create 3 by 3 array. Okay, so I need to give 9 elements and say reshape 3 by 3. I'll just display how it looks like. Fantastic, as expected. So I'm going to define another array. I'll just copy this one to just save time, and I'll name it as H. Okay, another array which has a dimension of 12, and it is 3 by 4 array. Clear? That's 3 by 2 and 3 by 4. Can we stack this? Can we stack vertically the 3 by 3, 3 by 4? No, it's not possible. Let's try. It's going to throw me an error. I would say np vstack. That's a command. Vstack stands for vertical stack, and I would give z comma h, and I'm expecting an error now. So it's going to say, hey, you know what? How do you expect me to stack a 3 by 3 and 3 by 4? Because you can't really stack the word. If you want this to be working, I can say 4 by 3, so that you have 3 columns and 3 columns here as well. Now it makes sense that it should be stacking it. Now you have a fantastically stacked G and H together, as this is G and this is H. That's a tiny little very useful function. As you might expect, we also have H stack. Okay, I create another array, np.arange. Okay, I'm going to just copy the same things from here. Just saving time. I keep it as same array, and I also have another array, ij, and that is, no, I'll keep it as 3 by 4 or 4 by 3 or 3 by 4, because it's horizontal stacking and there's 12 elements. I can print these 2 arrays in one command. I'll use print. If it's just one element, you don't use print normally, you just give that element. 2 elements of print. So I have 2, of course. It's not looking nice. I would be rather printing it nicely. Okay, so that's your I, this is your J, alright? And I want to stack them horizontally, alright? Simple command, np horizontal stack sh stack, sorry, and you say I comma j. Okay, and you display, it will display by itself. It's gonna say that okay, 3 and 3 H stack. Oh, sorry, so I keep forgetting this. So this has a different syntax. I'll explain you why it is, but this is how it is. So this is your I array, the first 3 rows, and then the next four columns or actually j array. So they have been stacked. All right. So similar to the range function, which basically gives you a serial data, we have another function called as random to generate random data. Let me see what is this random data does. So when I say random, that is the package, sub package within Numpy, and the function name is random. And it gives me a weird number, right? A big one. So what is it? It just generates a random number between 0 and 1, right? And it randomly generates. If you execute one more time, it gives you a different number. If you execute one more time again, it gives you a different random number. And using this random function, we can generate the entire array. And that actually can be used for creating a random arrays. So let me just generate an array using this random function. So it's random dot random, and I can provide the dimensions directly here. All right. So just you have to do a 2 parenthesis stuff here, and I want to have a random array of let's say 2,12. So okay, that's too much. I'll put 6 here so that I can see in the screen properly. So even 5 might be even better, so that it comes in 1. Okay, great. So I have 2 rows and 5 column array, 2-dimensional array, which has all weird numbers because they're randomly generated. If you execute one more time, you have completely different numbers. All right, and this looks really good. But I rather work with simple numerical numbers rather than this weird 0.3265 kind of number. For this, we have a command to actually round it up to the nearest integer. If you want to round it up to the nearest bottom integer, the command we use is np.floor. The floor means the bottom. Floor is under your feet, so that's the same meaning here. So floor, I can say floor and pass on this entire thing to it. All right, and then I execute this. Well, I'm going to expect all zeros because these are all between 0 and 1, and obviously when you go to the lowest number it becomes 0. But what I can do is I can multiply this with 100 directly like that, and I get nice numbers: 70, 44, 25, 12. These are all bottom numbers. Okay, so what does floor do? Floor simply, I can pass on any number like 10.4 for example. So the floor gives me 10. It rounds it up to the nearest integer, the lower integer, which is a floor. As you might expect, we also have something called as ceil. Flooring and ceiling. Ceil does the same thing, but it rounds it up to the upper number. The same, if you go pass it to ceil, it gives me 11. Here it's giving me 10. And these tiny little functions can be used to round up the big numbers and make some meaningful arrays. Okay. All right. Let's move on to the next function, which I'm going to create a quick array of 2 by 6 using floor and random. Okay, IGKLM, just using the serial numbers. Great. So I have a nice array which is 2 by 6 with the random numbers, and I want to split these arrays into 3 arrays, each of 2 by 2. There is a nice command called np split or numpy horizontal split called as hsplit. I can pass on my array here and say how many times I want to split it. I want to split it 3 equal parts. So it's going to give me 2 by 2, 2 by 2, and 2 by 2. Okay, and I would print this. Okay, as expected, this is one array, this is another array, and this is another array. Okay, and this tiny little function helps us to split the arrays as convenient if needed. I'm not talking about the use cases yet because that we will discuss in further data science tutorials. This is to just familiarize functions in Numpy package. Okay. As you might expect, we also have vertical split. You can experiment by yourself. So it basically splits up array vertically. So let me create a quick array one more time. Array n, and this time I would say it is 6 by 2 or 8 by 2. Okay, and this is a 8 by 2 array. Now I want to split this 8 by 2 array vertically into two parts. So I can simply pass on my n array and say divide into 2, and as expected you will see there are two arrays coming up, 4 by 2 and 4 by 2. Okay, and that's mostly what is useful or the key things in Numpy. And the last thing I would like to discuss is when you want to copy an array. Let's say you have an array called A or MNP. We have an array called P, which is array, and I just give a static numbers 1 2 or 1 2 3 4 5. Okay, just a simple array. Okay. A simple one-dimensional array with 5 elements. I want to assign these values or copy this array to another one. Let's say I have another array Q. I call it as P is equal to Q. What do you expect? You get a copy of P stored in the Q. But that's not true, because in Numpy, when you do this, Q is equal to P, it's not creating a copy of it, it's actually creating a reference of it. What do you mean by that? So I have now two different arrays, right? P and Q. If I look at what is in the P, what is in the Q, it's exactly the same. Let me change something in the P, all right? P is, I can refer the P elements directly by using the index. So I want to change this 4 to 400, okay? That's fourth element, so I have to say 3 here, and I can directly assign 400. Now, if I look at P, it gives me 1, 2, 3, 400, 5, okay? But you know, from a common sense point of view, the Q should not have been changed. Let's check it out. Oh, what happened? Q also changed. So what's happening here? Q and P are referring to the exact same location where the data is stored. This is not what we expect. What we expect is to make a copy of it. If you want to make a copy of it, you should say Q is equal to P and copy. Copy is a small function. P dot copy. If you do this, then you have a separate copy of P in the Q. Now let's change another. This is a P. Now it's exactly same because we just copied it. Now let me change something in P. I'm gonna make 200, 2 as 200. Okay, and see, this is here. Now the P has become 1, 200, 3, 400, 5. Let me check what is Q. The Q doesn't change here because now it's a copy. This is something which you have to remember, because I see most often when you're doing a data science analysis, we kind of like assume that when you do array is equal to another array, we expect it to copy. You just have to remember this. And this is a very essential part 1 of Numpy Python. We discuss about other things in part 2. Alright, so hope this is useful, and thanks for watching.